Use synthetic division to divide each polynomial. Start with the coefficients. 1, -9, +9, and 43. And draw a box around that, leaving enough room right here for another row of numbers. So then you want to take this thing that you're dividing by and find the 0. So of course the 0 is 7. We're going to write that number right there. X equals 7. We're going to write it outside of the box. Now the rules are add down, multiply, diagonal. Add down, multiply, diagonal. So you start with that number 1 and you add down. Well, there's nothing to add, so you just basically bring it down. And then multiply diagonal. 1 times 7 is 7, and it goes right there. So just repeat those steps. If you add straight down, -9 plus 7 is -2. And then we're going to multiply diagonal. -2 times 7 is -14. Add straight down. 9 plus -14 is -5. And multiply diagonal. -5 times 7 is -35. Add straight down. 43 plus -35 is +8. And we're out of room, so we're finished. And so those numbers down there at the bottom represent our answer. We just need to put the variables back in to show that it looks like a polynomial. So basically what happened was we started with x to the third, and we divided by a power of x. So if you think about it, if I start with x to the third and I divide by a power of x, I'm going to end up with an x squared, and that's what we're going to have here. Our first term is going to end up being an x squared, and then you count down from there. There's an x, there's a constant number with no x's, and then this one's going to be a fraction. So we've got 1x squared. Here's our answer. X squared minus 2x minus 5 is the constant, and then plus 8 is the numerator of a fraction divided by what we're dividing by here, x minus 7. That's synthetic division. We could have done long division, but synthetic division, most students find that easier. Number 19 is pretty much the same thing. We're going to use synthetic substitution to evaluate the function at the given value. So there's a couple of differences, but mainly we're doing the same thing. Let's start with these coefficients. You've got a 1, a -8, 17, -8, and -14. Draw the box around it, leaving the space. Now here's the first main difference. They give you that x number, so use it. If they give you the x number, use it. And then we're going to do our process. Add down is 1, and multiply diagonal is 5. Remember, multiply diagonal. Add down is -3. Multiply diagonal is -15. Add down, 17 plus -15 is 2. And multiply diagonal is 10. Add down is -2. And multiply diagonal is -10. Add down is -24. And we're out of room, so we know we're finished. So the thing that's kind of neat here is when you evaluate this last number right here is the answer. The answer to this problem is -24. Or f of 5 equals -24. That's the answer. Another way of doing this problem is just to take 5 and plug it in. Plug it in, plug it in, plug it in, plug it in, and evaluate. So if you did that, you should get the same exact answer, -24. Last one says use a polynomial regression calculator to find a cubic model for the data. So they're telling me it's cubic. I know the answer is going to have an x to the third in it. It's got to be cubic. So let's use that regression calculator. So we used this in one of the lessons before. Find the one that says polynomial regression. This one. So you go in this yellow box and you're going to enter in those numbers. Remember, there's no comma. -3 space 2 -1 space 2, 1 space 10, 3 space 74, and that's it. So remember, they told me it was a cubic. So I know this is a degree 3. I'm going to hit calculate, and it's going to give me my model right there. Notice the r² value is 1. That tells you that this is a really good model. But right here is what we want. Y equals x cubed plus 4x² plus 3x plus 2. Just double check. X cubed plus 4x² plus 3x plus 2. Yep, that is the cubic model. And what that means is we found an equation that fits these data. If you plug in 1, you're going to get 10. If you plug in 3, you're going to get 74. And I know that's a good estimate because that r² value equals 1. That means it's pretty much perfect.